Okay. Hi guys. Yeah, this is all about it's a course introduction about object-oriented programming, and this is the principle is about programming in large scale. Okay, the keyword is all about programming in the large scale. So if you are programming in a company or somewhere else where you have to do a lot of programming, okay, management, so we use object oriented programming paradigm as a tool, okay, to program and manage the programming code. Okay, so this is the idea. So what is done here? Okay, object oriented analysis and design. Okay, we go and check out object oriented analysis. Okay, it's about some analysis is done there, and some designing concepts is also shown here. Okay, you will also be able to answer following questions. Okay, this is the most important keyword you have to understand is the questions. So what is an object oriented approach? how do how to think in terms of object and classes. Okay, how can we model the programs here in object oriented? So these are the key questions that you have to understand. So the learning part, and the learning part, what is the most important learning part here is we learn Java syntax here. Okay, we learn how to code, we learn how to test, we learn how to debug, okay, the Java programs, each and everything, right? So overall, this design especially is for Java exam test preparation for all those students who are like preparing the test for Java examination. They should try this course. Okay, here I try also give just the summarized version. Okay, just the idea. Okay, the idea is the key ideas are shown here, the concepts for each and every topics, and the topics that we will discuss, okay, is mostly about the Java environment, Java basic concepts, Java inheritance, Java collection framework, Java generics, okay, Java exceptions, and the input output, okay, in Java. So the sad part is like topics, this kind of topics like graphic user interface and the threads, these are not included in the topic that I will show you. It's like something like a basic introduction of everything, right? So the way of teaching will be all about answering the questions. The answering the questions means there will be some kind of questions, and I will just try to answer them based on the some summarized answer. It's just like giving you the key idea, key concept, okay, behind them. It's just about the preparation. Okay, so just this, okay, in this part I will just give you some kind of like summarized version. Okay, so like how we are going to do with the the lecture. Okay, this is just a sample. So what is the most used programming paradigm and what are the difference between them? Okay, so the better thing is to understand what are the types of programming paradigms that we use and what are the difference between them. So the first thing is like the first one. Okay, the programming paradigm is procedural programming paradigm. Okay, like some programmers already have used, some students already have used like C programming, right, for example. So we also have the second one is object oriented paradigm, like some students like they will use. Okay, this is the topic which is mostly focused towards is object oriented paradigm, that is Java. So problems in this procedural programming, what are the problems that you will encounter here in the programming language that you used before, that is C programming language. Okay, so the problems that you might encounter is a problem that we have is like we have no constraint on read or write relationship. Okay, for each functions, that means any external functions can read or write the vector data. What is vector data? Vector data means the data variables that you declare. Okay, and so vector data also means the declared variables that are used in the main function, right? So each and every functions that you declare can read or write, okay, any external function that can read and write the main functions data, okay. So this is the problem, because any functions can come and just read, okay, any functions can come and just write. So this is the problem, okay. This will create a problem later on. Why problem, we will discuss later, okay. Any on the long run, and okay, look, the long run this leads to growing number of relationships. So yeah, this is the problem is the relationship is there between the functions, the external functions. So each functions are having relationship with each other, and later on the source code becomes difficult to design and maintain, okay. So, and this is the problem that is quoted as spaghetti code. So the idea is like each and every functions, the external functions can read and write the vectors data. So on the long run, means on large programming language, so on large programming, like large programming, like you will get some kind of a relationship, so many huge relationship interconnected with each other, like a wire, like a spaghetti, so many code, okay. So this external function having relationship with this, and this is having relationship with another one, and so it's like it's some kind of networks, because so much, like it creates some kind of problem. And the solution that we will discuss is the same thing we are talking about. Is the solution is object-oriented programming language, which will help you manage in the large-scale programming language to reduce the relationship between them, and that's the idea. Okay, now, so why object-oriented paradigms is better? Why this is better? What is the key concept behind this particular object-oriented programming being a better programming paradigm? Is here we create objects, okay. So the key idea, the concept is how we manage the large-scale programming language, that is managing by creating objects, okay, not functions. Like we create directly the objects, and these objects has encapsulated something, that is data and the procedures operating on the data, okay. So we create objects, and on these objects, like we have encapsulated data and we have encapsulated procedures, okay, that is operating on the data. So everything is hidden, okay, hidden inside the object. So whenever you use an object, so you just use the object, okay, without having some kind of prior knowledge about what is inside the object, what is inside the object, that those are all hidden, okay. And this very property is of encapsulation is the reason which helps us to maintain very large programming even by a single person, okay. Even a single person can write a huge chunk of code, okay. So like it makes things go easier, coding easier, okay, in a large scale. So we can also reuse or reuse the code without knowing the clear picture of what is going inside, okay. So we don't need to go so deeply, okay, on the surface, like it's like just swimming on the surface, right, skimming on the surface, like surfing on the surface. It's like surfing, okay. So we can build some complex system with this approach. So this is the reason why we use object-oriented paradigms. Okay, now for the designing part we use what is, okay, like, okay, let's say what is UML. Okay, for the designing part we use mostly for designing the system we use unified modeling language, and this is the one we use. It's a unified modeling language, and it is something that is used to graphically visualize, specify, construct, document the object-oriented system. So any programming language, we program to make a system, okay. So usually programmers program to make a system, and the program is overall a system, okay. We do some programming for a system, right? So how do we visualize? So what is the tool to visualize it, generalize it, okay, to see it, specify it, okay. So we use this kind of language, that is UML, Unified Modeling Language. And in this modeling language, like we can what we can do is we can specifically draw several diagrams, okay, some specific diagrams to just visualize it, and that is class diagram, activity diagram, use class diagram, okay, sequence diagram, state charts. So all this is done here, and the tools for class diagram are like object aid, okay. You can like go to the link, through the link, and just try it out. Eclipse UML from Omondo. So just go through this link and just try to use it. Try to just think about it. We'll not discuss more about the UML, Unified Modeling Language here, but I will strongly suggest you guys to just go and just try it out, okay, and check, because it's just for to visualize your model. It's like modeling your system. Like before coding, thus you need to visualize, okay, that's like check it out, like what is the system, on which system, and how the system works. So on that basis you just do programming. It's like something that is some kind of some graphical concept, the concept, and on this idea and concept we do programming and coding. So this is the idea. And what is the relation between objects and classes? Objects, okay, class, okay, is a type of definition, okay. Definition is what? It's like something that is defined, okay, something that on the basis of something, like we create something, so it's like something, some root, okay, and the objects are created from this class, okay. So the idea is like we have a type definition, that is, for example, string, okay. So and we create objects that are different of string, that is a new string of type string, okay. So something like a object is created from the class, and class is something that is a definition, something a type, something is already defined, okay. This is the idea. Now instantiation, okay. So what is instantiation? It's like process of creation of objects, okay. And what is instance? Is like created object, right? And the created object is independent of each other, and we can create unlimited objects, okay. So there is no limitation for creating the objects, okay. And each created objects, they are independent of each other. So the idea, this is such a grand idea. It's like something that is some bug-free idea, okay. So something that is conceptually, it is very error-free, okay. It do not have some kind of relationship, okay, among each other. They are independent of each other, and we can have unlimited objects. Okay, how do objects communicate with each other? So how do they are independent, but how do they communicate with each other? Is the simple idea about message passing. So they just pass the message. So object 1 pass the message to object 2. So from this concept they just pass the information, okay, and which is not a procedural call or not a direct access of object data, okay, object's local data. What is interface here? It is just a subset of methods that rest of programs are allowed to call. The benefit of encapsulation is used in interface, that is, no knowledge of internal are necessary, okay. The idea of interface is something that is subset of methods. All the methods, okay, method are something that is operating on objects data, okay. So all the rest of the programs, they are allowed to call this kind of method, and that is the method, and that the collection of this method is called interface. The interface is something, a collection of methods that other programs are allowed to call, and it consists of some kind of methods that can be called by some other programs. So this is the idea behind it. What is the method? A method is something that is performed on an object's data actually, okay, the attributes inside the object, okay. So it helps to operate, we operate something on object's data, okay. We just try to edit or change or something, like extract it, okay, check out the information. So this is done in the object. Yeah, what is and why of using inheritance? Inheritance, like, okay, as I told you, like, we have something. What is and why of using inheritance? Let's check it. What is inheritance? Inheritance means something like a class, a new class inheriting something from a already existing class. Okay, what is already existing class? Already existing class means superclass that is inheriting something. There is inheriting something means that is inheriting all the properties of this superclass to create a new subclass. Okay, so this is called inheritance. Inheriting all the properties. Properties means it can be attributes, data, like methods, okay, information, so everything, okay, like data and methods. In short form, we inherit data and the methods of the superclass. So this is the idea. Yeah, and the new class, subclass that is generated, which inherits property from the superclass, has already the methods that can be overridden. Okay, all the overridden methods are there. Okay, we can override the methods that is inherited. Override means we can edit on the basis of our priority. Okay, we can just edit on the basis of the priority, or we can add more features. Okay, we can add more new things, more new method out of it. So this is the idea. And we can also use inheritance cause like something sometimes okay, so also inheritance is some feature that helps us to make coding very fast, okay, more simplistic. And why of using the inheritance? Why is the reason for using inheritance is because as I already told you, sometimes the new class you want to generate is merely some changes. Okay, the class is barely different from some already existing class. So the it's like something like extraction. Okay, something that helps us to reduce the coding time, because sometimes the new method we create, new like class we create, is barely a change from the existing superclass. Okay, yeah, this is all about the introduction part. Then we will deal more about this on the later classes. Okay, we'll go like serial wise. We'll go through the environment, concepts, then inheritance, framework, generics, exception, input output. We'll go through all these concepts, okay, from top to bottom, and just like we'll just try to make things easier. That's it. Okay.